A literal equation is simply an equation with more than one variable. Now, just a note on variables. If they write something like this, area equals pi r squared. Pi looks like a variable, but it is actually a number. It's a real number that we can find on the number line, and so you need to not get sucked into thinking it's a variable. The only variable in this would be the r squared. So just know, literal equation is an equation with more than one variable. And sometimes we have to practice solving literal equations for one particular variable. A lot of the times it's going to be to solve it for y for easier graphing. So in the case of number 1, what we're going to do is we're going to find what part has nothing to do with the y. And if we look, this 4x, it has nothing to do with the y. It's going to be easy to get rid of. So we're going to eliminate it by subtracting, because right now it is plus 4x minus 7y equals 12. So we're going to do the opposite, and we're going to subtract 4x from both sides. Now, some of you might have gotten used to seeing the 4x written first, the minus 4x. That's okay. You can write it as negative 7y equals negative 4x plus 12. And in fact, when we get to the solving equations, graphing linear equations chapter, we will do this. Next, is there anything attached to the y? And right now it's negative 7 times y. So we're going to do the opposite of times, and we are going to divide all the terms on both sides by negative 7. So this is now y equals negative 12 over 7 plus, because remember, 2 negatives makes a positive, 4/7 x. And you can write it like this, or to make your life a little easier, what you could have done is divide this side of the equation by negative 7, and divide this entire side by negative 7. The only problem is with your, in most math books, they don't like to see this negative in the denominator, and they would want you to change it to y equals positive 4x minus 12. They would want you to distribute the negative along the top and make that a positive 7. I don't really care if you do that. You could leave it with a negative 7 on the bottom for now. Now I want you to try doing number 2 on your own. And again, remember, if we're solving this for y, is there a term that has nothing to do with the y? And that would be this. Since it's a plus 2x, we're going to subtract 2x from both sides. So hit pause, solve this for y, and then you can check your solution. Okay, y equals negative 5/2 plus x. And you might think, how did that happen? Well, we're going to subtract 2x from both sides. That needs to go. And I'm going to be left with negative 2y equals 5 minus 2x. And now I need to get y all alone. And this is negative 2 times y. So I'm going to do the opposite of multiplying, which is dividing by the negative 2. Everyone on the other side has to get a negative 2. And I'm going to get that y is equal to negative 5 over 2 plus x. Because remember, negative 2 over negative 2 is a positive 1. Now this last one we're going to try out number 5. This last one we're going to do is a bonus type one. Not because solving for x is hard, but because in number 5 we have 3 variables, and this one is a little bit uglier. what we're going to do is we're going to get rid of any one that doesn't have x involved with it. And that would namely be the 3. The 3 is going to go. So we're going to subtract 3 from both sides. And I'm going to get 5x minus kx equals y minus 3. Now, the only thing I can do is I can't just divide by 5 and then divide by k. This is not really what we want to do. Since both of these terms have an x in them, I think we need to take out that x. So if we divide out an x, if we factor out an x, we are going to be left with 5 minus k. And that still equals y minus 3. So now it's easy to get x all by itself. You have x times a bunch of gross stuff. How do you undo times? Divide. So we're going to divide by this gross stuff. 5 minus k. Divide this by 5 minus k. And this is now a thing of the past. It equals 1. And this is what x equals. X equals this gross mass, y minus 3 over 5 minus k. Skip ahead to the next video to get your formulas. Sometimes they will ask you to take a formula that is given, such as simple interest, I equals PRT, or distance equals rate times time, and they will want you to solve it for a specific variable. And that's where being able to isolate that one particular variable is helpful. For example, with distance equals rate times time, if we needed to find out how long something was going to take, we could just isolate the t right now. So distance equals rate times time. What is the opposite of times or multiplication? It is division. So if we want to isolate the t, then we're just going to do the opposite of multiplication. We're going to divide by the other variable, r. So we divide both sides by r, and then we could find out that time is the same thing as distance over rate. Now, what I prefer to do is plug in everyone I know and hope there's only one variable left and then solve for that one variable. But we do have to be able to isolate a single variable given a gross formula. So they want us to rewrite the given formulas here for the variable. So let's try something a little fancier like 3. If they want you to get f all alone, anything that's in the numerator or denominator has an imaginary set of parentheses around it. When you solve an equation, you do the order of operations backwards. So the parentheses are the last thing we're going to look at. This is f plus h all divided by. We need to get rid of this divided by 3. And we're going to get rid of it by multiplying both sides of the equation by 3. And now there's no more 3's. And we're left with 3y is equal to f plus h. Now, what is the opposite of addition? These are both positive. Subtraction. So we are going to subtract h from both sides. And now we get that f is equal to 3y minus h. These are not like terms. We cannot combine anything. And now you've solved it for f. If in number 4, you are a visitor to the United States, you don't know about Fahrenheit, so everyone else in the world would want to use this formula to convert our temperature into centigrade so that they would know how many degrees Celsius it really was. But like our Australia and New Zealand problem, we want to convert this, we want to solve it for f. So, who has nothing to do with the f? Well, that is the 5/9. It's on the outside. So now, since there's a parenthesis there, we have to get rid of everyone who's on the outside of the parentheses. And it's a 5/9. So we're going to multiply by the reciprocal. we're going to multiply by 9 over 5. So I've got this equation over here. C equals 5/9 times F minus 32. And I'm going to multiply by 9 over 5. I'm going to also multiply this side of the equation by 9 over 5. 45 over 45 is 1, so this is gone. And now I'm left with 9/5 C equals Fahrenheit minus 32. All right, what's the opposite of minus 32? Plus 32. So let's add 32 to both sides. Again, these are not like terms. So Fahrenheit is going to equal whatever 9/5 Celsius is plus the 32 degrees. And that's how you convert Celsius to Fahrenheit.